Hey guys, welcome back to Heiko Prints. This morning I want to cover two things in this video. The first thing is going to be a follow-up on my most recent Z-off in Clipper the right way, ? I just want to go over, not so much nitty-gritty, the details of how I do it, but rather a comparison between two different trains of thoughts. But we're going to do that right over on my printer. It's a little easier to understand what I'm talking about when you actually look at it. And the second part, I want to look at a modification that I did on my Solval SV06. A lot of people in the comments have asked about it. They want to know, all the individual items, the pieces, how I did this modification to my printer. And I just want to put this in a video. I will put all the parts, bits and pieces that are required to be printed or to be purchased down in the video description. All right, let's just get right into it. All right, so first part of the video, we're going to be talking about the two competing methods of doing Z offset, with a feeler gauge or with a piece of paper. Let's start with a more common method, which involves a clean sheet of paper. Initially, I took filament out. I unloaded the filament, so it's just hanging here in midair, and I heated up my extruder to clean off the nozzle. I want a perfectly clean nozzle, because if you have a piece of filament sticking out of your nozzle, that might skew your result. Here's the tip of a nozzle, as you can see, pretty pointy. So first step that we're going to be doing in this more traditional method here, you can see what I'm doing on my little clipper screen here on the side. Let me swing you around a little bit more so you can see. I am just going to home all axes. So it runs into physical stop, X and Y, and then it's going to probe the Z-axis. And the computer really only knows the trigger point of the inductive sensor. This is an inductive sensor, so it's a touchless or non-mechanical Z offset or Z probe. You need a metal build sheet for an inductive sensor. If you would forget to put your metal build sheet on it, the extruder is going to crash into your bed. It's triggered by the metal in this build sheet. If there's no metal, it will not stop and just keep going and crash into your bed. So now the computer knows the trigger position of this probe. It does not know where the nozzle is. So the little pointy nozzle here, the computer has no idea how high above the bed that is. And in this Z offset calibration that we're going to be doing is where we're going to tell the computer or the differential between the position of the probe and the nozzle. So the nozzle tip is X amount of travel from the position of the probe. Here on Clipper screen, but you can also do that in Mainsail itself. On Clipper screen, we have a Z calibration function that I just click on, and then I start it. On Mainsail, if you go into a console, there is it's called probe calibrate. So probe _ calibrate, you punch that into your console and it will start the same calibration process. So once I click start up here, it will probe one more time to establish where the probe trigger point is, and then it's going to move the nozzle into the same position where that probing just happened. Then you're going to put a piece of paper on here, and don't forget, this Z calibration, either on Clipper screen or in Mainsail, is supposed to be done with a cold printer. Right now my nozzle is at 56 degrees Celsius and my bed at 32. Not 100% cold, but close enough. You're supposed to do that in cold conditions. So now, here at the bottom, I can choose how much I want to move my nozzle, either up or down. Let's do 0.5 millimeter at a time. And I'm just going to lower down my nozzle until it touches my piece of paper. So now we have the nozzle pinching the piece of paper. This is a little too hard, so I'm going to go to like 1/100th of a millimeter and slowly raise it again. I want just a little bit of friction, not much. I want to be able to push the paper back and forth under the tension of the nozzle here. Kind of like that, maybe one more. So like that. So now we're pretty much telling the computer exactly how far it has to go down from the probe trigger point until the nozzle is touching the bed. Here in this case, we now have a piece of paper in between the nozzle and the bed, which in a way it protects the build surface. They always say a piece of paper is about 1/10 of a millimeter thick. As you can see here, my caliper, 1/10 of a millimeter. It's probably a little less. And why they use a piece of paper is you're doing the Z offset adjustment in cold condition. Once you start heating up your printer, all the metal parts are going to expand, and this 0.1 of a millimeter between the nozzle and the bed is going to shrink down to almost 0. And that's the whole idea. So you want this to be tight, but not too tight. So I usually take a full sheet of paper, and as long as I can slide it back and forth like this, it's fine. Make sure the nozzle is clean and you don't have a piece of plastic stuck to the tip. That's why I unloaded filament. So now, next thing we need to do is just accept our adjustment, and the same can be done on mainsail. Let's do that real quick. All right, guys, so let's do the whole probe calibration. That's the more traditional method with paper. Once again, here on the mainsail interface. So down here in the console section, I like to go to the little question mark. When you click on the question mark, there's a search function where you can search for commands that you can trigger here. And there's all kinds of stuff. So hyperlapse has to do with time lapse, taking pictures of your prints. Park front, you just make your printer move to the front, or you can just type in the word probe, and under probe you will find a few: manual probe, probe calibrate, probe accuracy, so you can move your nozzle around to any position on your bed and then just do a accuracy test. But we want to do the probe calibrate right now. So now we have the command here in the console. We sent that. Then you're going to see your extruder probe one more time in the middle of the bed. Then it moves the... Oh, I can't move this, huh? This little window here pops up. So then it moves the nozzle to the same location where it just probed. And then you take your piece of paper and put that between your nozzle and your bed. And now we have to move the extruder down towards the bed. So here in the advanced section, you have very fine increments of how you can move the extruder closer to the bed. Let's do a couple millimeter increments here. That's very tight. So we immediately need to go up a little bit. So that's kind of the nice part about a piece of paper. It protects your bed even when the nozzle touches down pretty hard. So now with the plus section here, hundredths of a millimeter or 5,000ths of a millimeter, we can make very fine movements until the friction between the bed nozzle and paper is just right. And when you're happy with the result, you just click on accept. And then after that, you can do here in the upper section, click on save config. And then it saves the established differential between the probe trigger point and your actual nozzle position in the printer config. So here at the, if you go into machine to your printer config, the very bottom, it stores here, it says Z offset 1.351 millimeters. So your nozzle is 1.351 millimeters from the trigger point. That's pretty much what you're telling the computer. So, and now we did the variation with a piece of paper. And now I'm going to heat up the printer, and then we're going to do the whole thing I know my face is covering the temperature adjustment, but believe me, I'm going to put the extruder to 200 degrees, enter, and the bed to 60. Now we're going to take the piece of paper out of the way, and I'm going to home the printer one more time. So again, it runs against its end stops, X and Y, and then it triggers the probe. The probe trigger point is the Z end stop, so to speak. There's no mechanical switch, or in some fancier printers, they have load cells where the nozzle actually touches down in a certain location on your bed, and then the load cell measures when the nozzle touches the bed, and then tells the computer, okay, nozzle has arrived. Since we don't have a load cell here on this relatively budget SV06, we have to do what the load cell would do on a fancier printer. So temperatures have already reached what we wanted, 200 degrees on the extruder, 60 degrees on the bed. Now I'm going to grab my feeler gauge. I can pick any thickness. I can do a 1 millimeter, I can do 0.1 millimeter. It doesn't really make any big difference. The important part is that if you choose, this one here is a 0.4 millimeter feeler gauge, that you go into the Z adjustment for the tool head and punch in 0.4 millimeters. Then your nozzle gets to go down closer to the bed and sits at 0.4 millimeters. At least the computer thinks that your nozzle is at 0.4 millimeters right now. You guys pointed out, rightfully so, I should be doing the adjustment in the same location where I just probed. So we're going to go to X117 and Y117. That's roughly in the middle of the bed. And that's right where I just triggered with a probe, right in that location. So theoretically, the nozzle should be 0.4 millimeters above the bed right now. I have a 0.4 millimeter feeler gauge here. Stick that in there. I can't, it's a little too tight. So now below the tool head position adjustment is the Z offset adjustment. And that's what we're going to use to correct. You're going to see that here Z, it's still going to stay at 0.4 millimeters, but it's actually changing where that is. So it's correcting where 0.4 millimeters above the bed is. So it's too tight, so we need to go up. Oh, right there. So I moved 0.03 of a millimeter up, and you can see that here, Z offset 0.03 millimeters. In the Z position, it hasn't changed. And I just want a little bit of friction between the nozzle and the bed, just a little bit. If you make it too tight and then you wedge your feeler gauge in there, you are actually going to deflect the extruder. Here, let me demonstrate real quick. You're going to see it here on the camera. So you can actually deflect the extruder if you're too forceful. So you want the 0.4 millimeter feeler gauge at a Z position of 0.4 millimeters to just slide in there with just ever so slightly friction. Yeah, and that feels pretty good. And then the next thing you need to do here in the Z offset section is a little save button. You save that, and then the new Z offset has been calculated and registered. Click on Save Config to save it to the printer config and restart Clipper. Save. So now it put it into the printer config, and it's restarting the firmware. And now we can go back into the printer config real quick and see if we see any difference down there in the number. A little bit. So 1.321 millimeters. It was 1.35 something before. So yeah, that makes sense. So pretty much the main difference between the paper method and the feeler gauge method is that one is done with a cold printer, and you hope that due to thermal expansion, once you take the paper out and you heat up your printer, that the tolerances are going to tighten up, and that you're actually going to be at, you know, if I go in here into the tool head position and say 0 millimeters, that the nozzle will touch the bed. That's what you want. And the feeler gauge method is you actually bring your printer to temperature. And then when I say printer, go to nozzle 0.4 millimeters above the bed, that the nozzle is right at 0.4 millimeters above the bed. And like I said, you can do that with a 0.3 or a 0.2 or a 0.5, but you have to put the tool head at the correct position. So home the thing, and once it's homed, you type in the Z number corresponding to the size of your feeler gauge. Mine always just probes twice. I adjusted it. Always takes too long. So 0.4 millimeters, boom. Your nozzle goes down to what it thinks 0.4 millimeter is. You shove your 0.4 millimeter feeler gauge in there, and it should just snugly slide in there. Just remember, you want to do that with a hot printer. And I again forgot that you need to make sure that you move your nozzle to the position where you just probed. So roughly the middle. I've used this here is a paint marker. I just made a little white dot in the middle of the bed. And in the printer config, you can actually calibrate. Let me show you real quick. You can calibrate down here somewhere, heat bed probe. The probe offset. So here you're telling the machine the difference between nozzle and probe position. So the probe is 30 millimeters plus on the x-axis and minus 20 on the y-axis from where the nozzle is. So your computer already knows the difference between nozzle and probe position. And yeah, when you do the feeler gauge adjustment manual calibration that I do, that I just demonstrated, you want to move your nozzle to where the probe previously probed the homing, and then punch in Z, the same number that's written on your feeler gauge, and then stick your feeler gauge in there. If it's too tight, you go up. If it's too loose, you go down. And this gives you very fine adjustments. And then after that, click the accept and then the save config, and you're good to go. So those are the two methods. The other thing that I want to cover real quick, let me switch cameras here real quick. So the second thing that I want to cover in this video is a modification that I did to this printer. Here, let me move my tripod out of the way. So we're going to do this handheld. Some people have asked me about my pulley setup here. So I did not come up with this. I just printed parts that someone else already had designed. It's on codes3d.com, where I got all those files for this pulley setup. Why am I modifying my printer to have a timing belt, so to speak, between the two Z-axes lead screws? So the SV06 is equipped with two Z steppers, one here and one over there. Those two Z stepper motors, they are not independent of each other. They are actually wired in parallel, and they are going to the same electronic driver on your little motherboard. So they are not independent of each other. They always do the same thing at the same time. And in a perfect world, this printer, this here is the Z-axis, the X-axis gantry, right? The X-axis gantry, as it moves up and down, becomes the Z-axis. So this is, here, let me turn the steppers off. Disable motor, yep, accept. So this is X-axis, of course. If this gantry moves up and down, that's the Z-axis. And those two steppers are always doing the same steps, the same distance, the same movements, parallel to each other. Here on this SV06 in its original configuration, you don't have a timing belt up here. So when the printer is off, or when the two stepper motors are disabled, right now they're disabled, I can now reach here for the lead screw, and I can actually turn it, and then my gantry will go up and down. If you have a printer that doesn't have this timing belt, those two steppers can be turned independently of each other when the printer is off or when the motors are disabled. And when your printer sits here overnight and you have the printer off, what happens is the gantry will sag on this side. Here is the stepper for the x-axis. This is the stepper that makes those movements here. So because of that motor, that extra weight that hangs here on this side, and of course also some other misalignment problems that comes with those, you know, relatively inexpensive printers. So the things are not perfect in shape. They're not very square. They're not very well aligned. Then you at home, you're supposed to put it together, and you're supposed to make sure that every angle here is square. Everything is square to each other. All the verticals are perfectly vertical and all the horizontals are perfectly horizontal. When this printer is turned off, this side will sag. And most of the cheaper bed slinger printers, they have that problem, unless they have a timing belt between the two Z-axis lead screws. A lot of cheaper printers, they even only have one stepper motor, and then they have a timing belt at the top, or some have it down below the bed. And they actually drive two lead screws with only one stepper, and they are held in synchronization with a timing belt. Here in this model, since we already have two steppers, as long as they are powered up, they're going to hold this gantry straight, and they're going to move up and down parallel with each other. Once you turn this off, gantry sags on the left hand side, and then you can do a gantry alignment, which the Sovol printers do, the Prusa printers do. They just run the gantry all the way up. There are plastic stops up here. Here's a little stop, and literally the gantry will ram into those stops. And then you hear the two steppers, they will growl, they make like a noise, and they try to realign themselves. So both steppers will run into the stop, and after this gantry calibration was done, the idea is that your gantry is then parallel to your bed, and those two steppers were just forcefully realigned to each other, brought in parallel or brought into alignment. But unfortunately here on my SV06, even though I made sure that everything is square and everything is vertical and plumb and true and all that stuff, the gantry calibration just never worked out really well. So every time I would do that, and then I would do a bed mesh, and then on here on Clipper, in the bed mesh function, if I would have one loaded right now, you could actually look at your result, and my bed would always look like the right side is dropping off like this. In reality, it was not the bed dropping off, but it was the gantry hanging on the left side. So this gantry calibration just never worked. Then another idea that some other guy has come up with, and I've seen it now in a few different videos, is where you can use your Z probe. Yeah, if I turn my... You can use the little trigger light on your probe to find out where your gantry is in relationship to your bed. So you move your probe over to one side, then you can grab your stepper here, you trigger it, then you bring it back up just so that the light turns back on like this. Then you move your probe over to the other side, and you do that again. And now you do that a few times back and forth, the two steppers independently of each other, and eventually you will have your gantry perfectly parallel to your bed. But that only lasts as long as you then use your printer. If you let it sit for a while, it's off for a couple days, the left side is going to be drooping again. And then you have to start all over again. Of course, you could do that once every time you use the printer, and it's no big deal. But that was just not very good. And then sometimes I would forget, and then I would start a print, and then the first layer wouldn't turn out, and then I had a failed print. So then I looked around and I found this design where someone had already designed all those belt tensioner parts and the mounting brackets and all that stuff. And I will look if I can find a proper picture of this modification. But in the original form, this belt tensioner is a little lower, and the belt is actually here. in this level. So this little pulley that I have up here is sitting down here, and the belt is down here. In order for me to move this all up, to get it out of the way of the extruder comes up here, you know, gets really close to all this. So you lose a little bit of some printing height. And I didn't like that. So I ended up getting longer lead screws. I think the original ones are, don't quote me on this, maybe 360 millimeters or something like that. The new ones are 400. So they are just a smidge longer, maybe 380. And now the new ones are 400 millimeters. They are the same type of lead screw, the same thread pitch, and the same shape of thread as well. So you got to buy the correct ones. So they still fit with your Z-Axis nuts here, this one and this one. I just bought some longer ones. You also have to print those plastic parts up here. Originally, they don't have a bearing in it. I have bearings in there. There's a little inline skater or rollerblade bearing in it. And they have a hole here in the top, so you can literally stick your lead screw through. Then you have to print out the belt tensioner, the mounting brackets, and here in my case, because I modified it, I printed 2 of those brackets with heat inserts, with thread inserts. And it just happened so that when I used 2 of those brackets combined, one mounted downwards and one mounted upwards, that the screw holes just line up perfectly, so I could bring the belt tensioner up to this level. So now everything is out of the way. I actually ended up using some stainless steel washers down here just to shim it up to just the perfect position. And then I'm still running a filament sensor. And the other part that I printed, which was really necessary, is the motor mounts. These motor mounts here, they are reinforced on the side. The originals are just a L shape, and unfortunately they are not square to the machine, square and plumb to the machine. So the stepper motor shaft ends here in the middle of this little coupler, and they were always leaning forward a little bit. So they were not perfectly vertical, but like leaning forward a little bit. And that brought this whole coupler out of alignment. Originally, I tried to compensate that with flexible couplers. Here, let me grab them real quick. So here we go. So originally I tried to compensate the misalignment between the stepper shaft and the lead screw with just flexible couplers like these, but that didn't work really well. Here is one of the original stepper mounts. You can almost see it here in the video that these stepper mounts are not square. After I reprinted them from files that I will link down below, after printing these, the motor shaft and the lead screw align much better. And so then as the lead screw is spinning, you see there is less wobble in it. And then additionally, having the lead screw actually captured by a little bearing that's up in here. I will see if I can find a link to a bearing that fits right in here, and the file as well. You print those, get yourself a longer set of lead screws. I will link the pulleys, all the pulleys that I used for it, and also the model of this design here on Cults 3D. I put a link down below as well. And yeah, this is cobbled together a little bit. Like I said, this is really 2 pieces up here, but I made it work, and I have the pulley high enough that I barely lose print volume. So the original print volume is like 250 millimeters, and I have my clipper config currently set to 245. With 245, the extruder comes really high up here, but it doesn't touch anything. And that's what I wanted to achieve with this. So with now this mechanical connection between the right and the left Z-axis lead screw, you have no more sagging when the printer is turned off. I barely ever do a bed mesh. I mean, it does a quick bed mesh. It does the adaptive meshing before each print. That's part of CAMP. But I'm not worried about my gantry being out of whack anymore. So that's what the pulley system here is achieving. And there is not much load on here either. I mean, the lead screws are spinning very slowly when the gantry is going up and down, right? So the belt is moving very slowly, and there is not much tension on it either. This is really not a wearing part. It's just there to keep those two steppers in line with each other when the machine is off. And when the machine is running, they are doing the same thing at the same time anyways. There's another way of fixing this, which is electronically, but that would require for you to buy another controller. Get a controller that actually has two independent stepper drivers for the Z-axis. Usually those boards are then a little larger, and then you have to print another enclosure, and then you have to either recompile Marlin firmware or configure your clipper firmware so that you can actually address those two steppers independently. And then there is a way of doing gantry calibration electronically, actually with the trigger of the probe. So you can trigger here and then trigger here, and then the computer compensates for differences in the trigger point. But yeah, this is the mechanical variation, or the mechanical method of keeping those two Z-axis steppers in line. All right, guys, so that was pretty complex and long-winded. I hope you get something out of it. As I just explained, the pulley system is really only working when the machine is off. While the machine is running and the stepper motors on the Z-axis are energized, they are held in position anyways. So as long as you make sure the two Z-axis steppers were aligned and parallel and the gantry was level when you turn on the machine, it's all good. So that's why this pulley system works perfectly. I didn't see any reason why I would have to go the electronic route and get two independent Z-axis stepper controllers or stepper drivers, which requires a different board and a different enclosure and all that kind of stuff. With this mechanical method, I only took a few printed parts and a couple really inexpensive pulleys. The lead screws that I bought from Amazon, they were like 15 bucks. It was not a really expensive upgrade at all. But ever since I did that, I have not had a bad bed mesh. The gantry is not drooping on the left side anymore after it has been turned off for a couple days. And the printer is just more reliable. It's more accurate, and it's ready to go every time I turn it on. So yeah, I will make sure to put all the links of all the bits and pieces that I had to print, and also links to the longer lead screws and the pulleys that I used, and the long belt as well. It took me a little bit to find out what the perfect length of belt would be, and I found one that's just perfect, 696 millimeters. This of course only applies to the SV06. If you have an SV06 Plus or an SV07, it doesn't apply because they use a completely different motion system. But if you have a SV06 Plus, which has the same problem, they also have two steppers left and right, but they're not running independently. So you cannot correct the gantry position electronically. You can still do that on the SV06 Plus. You just need a longer belt. And of course, longer lead screws, because the build volume is much larger. All right, I'll put all that stuff down below, and you guys let me know what else you want to see. I mean, my printer is relatively modified. It runs Clipper off of a single board computer. I have Clipper screen on a little touchscreen next to it. I've done some noise reduction, so my extruder cooling fan and also the parts cooling fan, they are only running when parts are actually at temperature. I have a different enclosure for my power supply that I printed. Camera mounts. I have a camera light mount on the side. If you guys want to see any of that other stuff that you might have seen now in this video, just mention it down below in the comment section, and I might make a video about it. Alrighty guys, that's it for now. I will see you in the next one. Take care. Bye.